In Radix sort, we'll take our input data in a linked list. If the data is in an array, we can create a linked list from that array. Now in each pass, this linked list will be scanned and elements will be inserted into different queues. Now we don't know in advance how many elements will be inserted into a queue in any pass. It is possible that in a pass all the elements go into a single queue. For example, if we have all 3-digit numbers and all of them start with 9, then in the last pass all the numbers will go into queue 9. So if we take array allocation for queues, then we have to take the size of each queue to be equal to n, and the total space required would be n into 10. This is a lot of space, so it is better to take linked allocation for queues. So our queues will be implemented as linked lists. Now when we take this linked allocation for queues, we can use the same nodes of this linked list for our queues. We don't need to allocate any new nodes. Whenever we have to insert nodes from this linked list into different queues, we just have to rearrange some links. And whenever we have to combine queues back to the linked list, again we have to rearrange some links. And this has to be done in every pass. Now let us see the program for this Radix sort. This is the structure of a node of our linked list. This is the Radix sort function. And these two functions we have called inside the Radix sort function. And here we are testing our Radix sort function. This reference start will refer to the first node of our linked list. Here we are entering the number of elements to be sorted, and in this loop we are entering the elements one by one and creating a linked list. This function Radix sort will perform the sorting, and at the end we are printing the sorted list. Now let's come to this function Radix sort. Here we have taken these two lists to implement our 10 queues as linked lists. We know that the number of passes in Radix sort is equal to the number of digits in the largest element. So here we are finding the number of digits in the largest element through this function. Let's see this function. So this is the function which returns the number of digits in the largest element of the list. Here we are traversing the whole linked list and finding out the largest element. And then we are finding the number of digits in the largest element. And then we are returning those number of digits. Let's go back to our Radix sort function. The least significant position will always be 1, and the most significant position will be the number of digits in the largest element. Now in this for loop, k goes from least significant position to most significant position. So the total number of iterations in this loop will be equal to the number of digits in the largest element. And each iteration of this for loop will correspond to a pass of the Radix sort. In each iteration of this for loop, we'll do two things. First, we'll scan the linked list and insert nodes into different queues, and then we'll combine those queues back to linked list. So now let's see how this is done. First, we are initializing rear and front for all the queues to none. Now in this while loop, we are traversing our linked list and inserting all the nodes into different queues based on the kth digit. This function returns the kth digit from a number. Let's see this function. So this is the function that returns kth digit from a number n. Now we come back to our Radix sort function. Now after inserting all the numbers into different queues, all these queues will be combined back to linked list. And here we are doing this. First we find the first non-empty queue and initialize our start with front of that queue. After that, in this while loop, we are combining all the queues. This while loop executes till I is less than or equal to 8. And if I plus 1th queue is not empty, then we'll join end of ith queue to start of I plus 1th queue. And if I plus 1th queue is empty, then we'll assign rear I to rear I plus 1. And in the end, we'll assign none to link of rear 9 to indicate the end of our linked list. So this is how this Radix sort function works. Now let's run this program and see the output. So we can see that we got the sorted output. In Radix sort, the number of passes is equal to the number of digits in the largest element. And in each pass, we have n operations, where n is the number of elements. So the runtime complexity is order of p into n. And if the number of digits in the largest element is n, then runtime is order of n square. And if number of digits in largest element is log n, the runtime becomes order of n log n. So this sorting is good only if the number of digits are less. This is not an in-place sort since we need extra space for performing the sorting. And this is a stable sort, and that means it will maintain the relative order of duplicate elements in the sorted output.